All right, welcome back, ladies and gentlemen. I am actually at school today trying to work on some things and get stuff sorted out as we all figure out what's happening and how best to help you guys. So please keep sending in, suggestions to me if you're stuck or if you need help. Wait for us to have online classes, and I hope that these videos are helping. Otherwise, I wouldn't have made them. So today we're taking our second topic in our pre-physics unit. So we're not even still not even doing any physics. We're just talking about how to manipulate numbers. All right. So today's lesson is what we call scientific notation. Okay. Scientific notation is just a way that scientists change numbers that they're working with to make them less unwieldy. What I mean by that is when I have a really large number or a really, really small number, I don't want to write that number over and over and over again. Like, let's say I was like an astro scientist, and I studied the sun, and I happen to know that the temperature of the sun is 15 million degrees Kelvin. And let's say this is a number I had to work with all the time. I wouldn't want to write down all those digits every single time. So scientific notation is where we can take that number and condense it down and make it more palatable and easier for us to work with, okay? So what scientific notation looks like is like these two guys here, all right? This is the general form. This is it with some numbers because I find that students like to have numbers to it. But basically, scientific notation always looks like something dot something something times 10 to the power of d. If you're someone like me that likes numbers, like 1.23 times 10 to the power of 4, all right? Both of these show scientific notation. Both of my examples here have 3 digits before the time symbol. That's not always going to be the case. Sometimes they'll just have 1 digit, 2, 4, 5. It doesn't matter how many are before the time symbol. We'll talk about how we can figure out how many that's going to be later, not really the focus for today. But a couple things that we always have is this times 10. This is always going to be times 10. Okay, sometimes students ask me like, oh, will it ever be, times 6? No, it's always times 10 because 10 is what allows us to move decimal places. You guys should know that whenever we multiply by 10 or divide by 10, we either add a 0 or remove a 0 or move the decimal place. It's kind of the same thing. That's why we're using 10 here. And then the exponent that's going to be here really tells us how many times we move the decimal place, right? Which I know is a little confusing, so let's get into kind of the rules of scientific notation, and then let's get into some examples from your book. All right, so scientific notation has some rules to it, things that you just need to keep consistent. Otherwise, it just takes it out of the proper form that scientific notation should take. So the first two things here are just kind of rules that are actually pretty easy to remember. The first is whatever number or that decimal place that's in scientific notation, we can only ever have one number in front of it. So I can never have something like 11.4 times 10 to the power of 2, because here I've got 2 digits in front of my decimal, and I want that to be 1 digit instead, okay? So just make sure that you always have just 1 digit in front of this. This would be technically incorrect if you were to enter that answer on a test or quiz, which I still don't know what they're gonna look like. Please bear with me. The second rule, similarly, basically says that number that's in front of the decimal has to be between 1 and 9, which sounds dumb, and then you realize that just means it can't be a 0. So I can't have like 0.56 times 10 to the power of like 4, okay, because I have a 0 here, and that has to be a digit. It has to be 1 to a 9. Can't be a 0, all right? Again, this would be incorrect if you were to enter it as an answer. And then the other thing is that exponent can be a positive or a negative. Your notes talk about this a little bit on page 5, where it talks about positive versus negative exponents. When I have a negative exponent, all that means is I have a really, really small number, something like 0.00056, okay? So negative exponents come from numbers that look like this, right? Whereas positive exponents come from big numbers like that 15 million that I wrote on the last slide. Okay, so don't be confused if you see a negative number. It just means it's a really small number. Cool? Cool. Okay, so that's enough about like how to do scientific notation, or sorry, what scientific notation is. Let's talk about how to do it. There are 4 steps to turning any number from its standard form, which looks like this here, into its scientific notation form. If you follow these steps, this will work every time, but I find sometimes students get a little messed up, so I'm going to go through this a little bit slowly. Number 1, Determine how many significant digits you should have. We haven't talked about significant digits yet. We'll get into that next week. So for today, we'll say that we always want to have 3 digits. And I'm a bad teacher and messed up on my answer key because mine were all over the place. But today, try and round them to always have 3 digits just to get in that habit. All right. Second, what we want to do is take the decimal place and move it so that it's in between the first 2 numbers, first 2 significant digits, reading from left to right, okay? So if I look at this number I wrote down at the bottom of the page here, 40 million, right now it's got a decimal place that I didn't write down, but it's right there, all right? And what we want to do is move it so it's in between the first 2 significant digits reading from left to right. So as I go left to right, there's my first 2 digits, that 4 and that 0. I want the decimal, to be in between them. So I'm going to move that decimal and put it, and I'm going to put it right there, okay? No, sorry, I messed that up. I want to put it right there. There we go. All right. So now what I want to do, if you read the next step, it says we want to rewrite the number so that we have the right number of correct digits. Remember, we wanted 3 digits, so I'm going to rewrite this now as 4.00. Notice I'm now writing it where that decimal has been moved to, and I now have the correct number of digits, okay? The last step, and this is where we figure out that times 10 piece, okay? What I want to do is count how many spaces did I move the decimal. So starting with where it was, I moved it 1, 2, 3, 4, 5, 6, 7 times, okay? That number, that 7, that is going to end up becoming the exponent on our 10, okay? So now when I rewrite this, I have 4.00, correct number of digits, decimal now in the right spot, right? And now I'm going to write times 10, and then the exponent here is going to be this 7 that I just counted, okay? That's it. That's how this works. So 4.00 times 10 to the power of 7. I figured out where to move the decimal because it's in between the first 2 digits. I knew how many spaces I moved it, which gave me my exponent, and then it's always going to be times 10 here. We use a positive exponent here because I moved the decimal to the left and because I started with a large number, okay? So this example wasn't in your book, but the next 4 that I'm going to do are in your book, so please follow along. We're on page 5 where it says model. So let's hop to the first question here. All right, so here we want to take the number 230 and turn it into scientific notation. Take it from standard form to scientific notation. Right now, the decimal for this is right here, okay? We know that we want to move it in between the first 2 numbers reading from left to right. So as I go left to right, here's my first digit, here's my second digit, so my decimal needs to go down here. So I'm going to rewrite my decimal here like that. Remember, the next step is to rewrite our number with the correct number of digits and now with the decimal in the right spot. So now I'm going to rewrite this as 2.30, okay? Last step is we have to count how many times we move the decimal place and use that as our exponent. So I move the decimal 2 times, okay? So my number here is going to be 2.30 times 10, always times 10, to the power of 2 because I moved it twice. Again, I'm using a positive exponent because I moved the decimal to the left. All right? Basically, because I had a big number, I know I'm going to want a positive exponent. Next one. So this time we have 5,601. And again, we want to turn it into scientific notation. And I said with 3 digits, and my answer key is a little off this way, but we're going to turn this one so it's got 3 digits, all right? So please follow this versus the answer key that I posted on D2L, all right? So as usual, we're starting with our decimal place right here, okay? We want to move that decimal so it's in between the first 2 numbers reading from left to right, which is my 5 and my 6. So my decimal is going to go here, okay? So I'm going to rewrite that over here. Now we're going to rewrite the number. So now we're going to write 5.60. Notice that I said I dropped the 1 because we wanted 3 digits, all right? In my example online, I left it as 5.601. Don't worry about that. We're going to just leave it at 3 digits today because I want to get you guys in the habit of rounding, all right? Again, we have to count how many times we moved the decimal place. So we moved it 1, 2, 3 times. So my number here is going to be 5.60 times 10 to the power of 3, all right? All right, So this one here is our first one that's a really small number. It's the first one that's less than 1. And you can tell it's got that 0.000. That right there is your big clue that your exponent is going to need to be negative, not positive this time. All right? Just like before, we want to read or move our decimal so it's in between the first two significant digits, reading from left to right. We haven't talked about significant digits yet, but when you see what we call leading zeros like this, zeros at the front of a number, those are not considered to be significant digits. So we don't want to move our decimal here, okay? We want to move it to the first two numbers that are bigger than 0, all right? Which happens to be this 6 and this 9 here, all right? So here's our decimal place now. Actually, it's really easy to see. It's already on here, okay? And now we're going to move it so it's in between the first two numbers reading left to right, the first two non-zeros reading left to right, which is here. So we're going to move that decimal place to there, okay? When I rewrite the number, I'm going to rewrite it exactly like what I see here. So I'm going to write 6.98, okay? That gives me my 3 digits that I wanted. That puts the decimal in the right spot, all right? But just like before, what we want to do is count how many times we moved the decimal place. We ended up moving it 1, 2, 3, 4, 5, 6, 7 times, okay? So my times 10 here is going to be times 10, but because it's a small number, I want to use a negative 7. I move the decimal to the right, so I want to use a negative exponent. The way I always remember it is if I'm taking a number bigger than 1, like 230, like we just did, or 5,000 or 15,000, any big number like that, it's always going to have a positive exponent. Whenever I see something like 0 point anything, it's always going to have a negative exponent when we turn it to scientific notation. All right? Sometimes I find students get a little messed up, and they'll put the decimal between the 9 and the 8. Remember, we're always reading from left to right, not from right to left. So we don't want to do that. Always between the first 2 digits, going left to right. All right, let's do one more example, and then we'll be done. So same thing, we've got another small number, 0.00, okay? So that's going to tell us we're going to need a negative exponent, okay? Same thing as before, we're going to read from left to right, okay? And these happen to be my first 2 non-zeros. So I'm going to put the decimal there. Once I find my pen, there we go. So I'm going to put the decimal there. It was originally there, okay? Remember that we said we needed 3 digits? I asked you guys to round to 3 digits today. So this one doesn't actually have 3 digits, right? As it is, it's only 2.6. So all we're going to do is we're going to add a 0 to the end of that because it doesn't change our number, but it gives us the correct number of digits, which will become really important for us next week, okay? As like before, we want to count how many times we move the decimal. I moved it 1, 2, 3, 4 times. So I'm going to say 2.60 times 10 to the power of negative 4. And again, negative because it's a small number, all right? That's how all of these questions work. You guys should be fine to do the example questions on your own, although this is a little tricky, and I understand if you have some questions. I will be doing an online session tomorrow to go through any problems that come up and talk about these notes a little bit more, give you guys a chance to ask questions. But I'd like you to try the practice questions at the bottom of page 5. There's 4 down there that we didn't do. And then there's questions at the top of page 6 that go from A to J. Work on those ones, but please round them to just have 3 digits, okay? Always round those ones to 3 digits just to get in that habit. There is a boot camp on this stuff in case you need more practice, and the boot camp has lots of different versions. The thing is that the boot camp's a bit of an older one, and so question 1 gets you to do exactly what I was showing you today, turning numbers into scientific notation, which is really all you need to be able to do. It asks you to then turn scientific notation numbers into standard notation. Don't worry about doing those. So don't do the second question. The third question has you doing some unit analysis. You should be able to do some of those if you want, but a lot of them are those tricky ones, so I don't even recommend doing them. I'd rather you guys just do the first set of questions on the boot camp so that you get more practice with scientific notation, okay? Yeah, I hope this video helped. As usual, please let me know if there's anything I can do to improve it. I'm doing my best here. Hope you guys are too. Let's keep trucking through this. I miss you guys. I'll see you online.